Hi, Assalamualaikum. Today I'm going to talk about mathematical financial on the topic of one-step binomial model. So suppose that you are offered a European call option with a strike price of 100 and expiry or time frame of 1. This means that after you see what happened to the stock, you have an option to buy the stock, but not an obligation to do so for 100 at time 1. If the stock price is 80, you will not exercise the option to purchase the stock and your profit will be 0. If the stock is 120, you will choose to buy the stock at 100 and then immediately sell it at 120 to get a profit of 20. So our problem is to figure out the right price for this option. At first glance, they may seem impossible since we have not assigned probabilities to the various events. However, it is a miracle of pricing by the absence of arbitrage, and that in the case we do not have to assign probabilities to the events to compute the price. So a scheme that makes money without any possibility of a loss is called an arbitrage opportunity. It is reasonable to think that this will not exist in financial markets or at least be short-lived, since if and when they exist, people take advantage of them and the opportunity goes away. Using our new terminology, we can say that the only price for the option which is consistent with the absence of arbitrage, so that must be the price of the option. So to show this, to illustrate this, I will do some problems for as an example to show how the binomial model works. So that will be in the next video. Thank you. Hi everyone. In this section, I'm going to illustrate the idea of a one-step binomial model. Constructing a binomial tree is a useful method to price options, which represents the path of a stock price over the life of the option. The stock price is assumed to follow a random walk. It is one of the two popular ways to determine the price of a value of a stock option. The other alternative is the Balck-Scholes method. So I'm gonna show an example on how to find the value of a put option by solving the problem that I have here. A stock price is currently 50 ringgit. At the end of the 6 months, the stock price will either be 55 ringgit or 45 ringgit. The risk-free rate of interest is 10% per annum with continuous compounding. Calculate the price of a 6-month European put option with a strike price of 50 ringgit. So the first step to do is to list down all the information given. So we have here is the stock price is 50 ringgit. The strike price is also 50 ringgit. And the up magnitude is 55 per 50, which is 1.1. The down magnitude is 45 over 50, which is 0.9. And then the risk-free rate interest is 10%, which is 0.1. And the time frame given is 6 months, so 6 over 12 is 0.5. So let's draw the this is how draw the binomial tree model. So here we have the 50 ringgit stock price. So in 6 months, it either goes up to 55 ringgit or goes down to 45 ringgit. So this is how a simple one-step binomial option pricing model looks like. So the key to calculate this stock option is we define a portfolio that has no risk. So there's gonna be two positions where there is a long delta share, meaning the fractional share that we combine it with the position, where we take a short option in a short position in one call option. So by design, we make this portfolio riskless. So here, if the stock goes up, the payoff is going to be due to the long fractional share. This is going to be 55 times the delta, which is the fraction that we own with that we're going to find, minus the difference between the strike price and the long call. So in this case, we will be owing 5 ringgit. Then if the stock goes down, then we're still gonna own a fractional share of 45 times the fractional share, which is delta. So the call option now is out of money, and there is nothing to do there, and it's worthless to the owner. So since the portfolio is riskless, that means that these payoffs must equal to each other. Hence, we can write the up portfolio equals to the down one. So our delta must be equal, so we compute the delta. So it would be half. So our delta must be equal to 0.5. This means that our riskless portfolio is guaranteed for us if we own half of a share combined with a short position of the call option. So in either case, if we plug in a half of the share, the payoff of the portfolio is gonna be 22 ringgit and 50 cents. So now what we're going to do is we're going to discount it at a continuous compound rate at a rate of 0.1 and over 6 months, and insert the portfolio value to the present value portfolio value. So we have the formula here, which is PV equals to e to the minus exponential of the rate times the time frame times the portfolio value found here, which is 22.5. So the PV now is e to the power of minus r, which is 0.1 times 0.5 times the 22.5. That would be 21 ringgit and 40 cents. So the present value of our riskless portfolio would be 21.40 cents, and the put option value is half of the share minus the value of the call option, which is half of the 50 ringgit minus the present value, which is 21.40 cents. So that would be 25 minus 21.4, and so the option value here is 3 ringgit and 60 cents after 6 months. The option value will be 3 ringgit and 60 cents. So that's all from me. I have shown you how to find the option value from the problem given, and yeah, I think that's all for now. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh, and a very good evening. Okay, first of all, I would like to introduce myself.
Alah, spoil lah.
I would like to introduce myself first. Okay, my name is Muhammad Izzat bin Isa. Okay, my matrix number is 175321. Okay, for this student-centered learning task, I would like I've given a problem 4 about the stochastic process, which is basically this is about two-step binomial tree, which is yeah, before this we have learned about the one step binomial tree, and this one is the advanced step for us to count the expected or the present value for the two times calculating. Okay, first of all, the problem 4 is basically is about, as I said before, the two-step binomial tree, which is the stock price given is 50 ringgit, which is we have the magnitude up jump given is 6%, and then the magnitude of the down jump is 5%. Okay, so from here we know that the end time, or the uh, what I mean here is about the is paid in by 3 month. So we can say that for each 3 month we pay this interest, and then this given that risk-free rate is about 5% per annum, which is 5% per 1 year, and then 5% per 1 year. Okay, this is that's all about it for the problem 4 itself. Okay, for the question given, which is I need to introduce or to show the call option, the European call option with the strike price 51 ringgit. And then the second question, I need to construct the put option, the European put option for the given same price, strike price. Okay, pause. Okay, so from the given statement, we can see that the stock price, is S. We denote this as S, which is given 50 ringgit, and then the strike price is 51 ringgit, and given the magnitude for the up jump is we denoted as U 6%, so we plus 1 like this, and then the down we've denoted with D by 5, right? So 1 minus 0.05, we get 0.95. Right? So the risk-free rate, which is per annum, we denoted as R, given 5%, which is equal to 0.05. So next we need to construct the formula of the thing. Pause.
Hmm.
Okay. Next, okay, I've jot down the formula of the P, which is the exponent of RT minus the magnitude of the down jump over up jump minus down jump. Okay, pause.
Hmm.
Okay. Next, from the question above, we are asked to do to for the and looking for the call option, which is given the formula like this: F, we denoted as a F, equal to exponent -2, the risk rate time the period, which is uh, 1 over 4, 1 over 4 of a year, and then the given before this about the formula of P, and then we square it, and then we um, and then we times with the call option at uh, at the second point plus 2p times 1 minus p, and then the call option at the third point, and then the lastly 1 minus p we squared, and then times multiply with the third call option of the fourth point. Yes. All right, next we are asking to do the tree diagram. Okay, I have constructed it here, which is the given stock price, which is 50, and then we need to times with the magnitude of up jump. Then we get the magnitude of up jump, which is given 6%. We get 53, and then the magnitude of down jump, which is 47.5. Right. So next step also we do the same thing, which is the up jump and the down jump. And we get value of the up jump with from the 53, which is 56.18, and then the down jump of the 53 is a 50.35. Okay, from the 47.5 we times with the magnitude of up jump, we get 50.35, and then the down jump is a 45.13. And then next step we need to find the call option for this value, which is we denoted as a FUU, which is from the basic, which is from the stock price call option with up jump and up jump. That's why we denoted as a FUU. To find the FUU, we need to looking for the max of 56.18 minus with the strike price, which is 51, or 0. Okay, from this we get value max 5.18, 5.18 and 0. So from between these two we get 5.18, which is the max of the FUU for the FUU. And the second one, max between these two value, which is 50.35. Okay, when I max between these two we get 0. So 0, the max of this one we get negative value, and then the 0. Okay, 0 is larger than the negative value. We denote it as a FUD. Alright, the next one is the F1 call option for the down and down magnitude. Alright, so from these two we get the maximum value is 0. Okay, next we need to construct the call option, which is the formula of the call option, which is we denoted as F equal to the exponent minus to the power of minus 2 times the risk-free trade and times with the period. Okay, and then we times bracket here with a P2 times the call option for the up jump and up jump plus 2P times 1 minus P and times multiply with the call option for the up jump and the second and the down jump plus 1 minus P squared multiply with the call option for the down jump and the down jump. Alright, which is the given formula here, and then we substitute respect for the value given, which is we substitute each of them, and then we get the value, which is 1.635. Alright, so the call option, the value of the call option is 1.635. Okay, next we need to find the price option at the node 2, which is this is the node 2 of the 53. Okay, To find this price option at the node 2, we need to construct and have this formula. After we have this formula, we substitute the value and then we get the value, final value of the f. This we denote it as fu. Okay. Okay. Next. All right. Then we need to find price option at node 3, which is from the table, from the diagram here. Node 3 is here. Okay, we need to find here the price option here. To find the price option here, it's a given formula. It's look the same, it looks similar from the price option from the above one, but with different call option. Alright, yeah, we have different call option here and here. And then we substitute the value for the last value, which is given is 0. Right, for the call option of the downtown, we at node 3 is equal to 0. Alright. Alright, finally, for the European call option, we need to find the option price at node 1. Okay, node 1, which is here, which is the stock price. Alright. Okay, so we have given this formula. It looks similar from the before formula, and then we just substitute it normally, and then we get the value 1.635. Okay, now from here we can see that this value is the same as the call option before we've done before. Alright, it's the same value for the call option, 1.365. This is show that the call option is true. Alright, next, from the question above, we need to find the put option. Okay, this time we need to find the put option, but we have the same diagram here, same as the call option before, but this time for the call option here, call option for the up jump and up jump, we need to find the minimum. Alright, find the minimum of this value. Okay, from this top one, the minimum value is 0, but this here we find the minimum value of here is negative 0.65, but we didn't take the negative because we are looking for the mean, and then we get 0.65, and next the mean of the farm call option for the down jump and down jump, we get 5.87. Okay, for the put option here, we need to find the put option called here, which is given the same formula as the call option before here. We just need to substitute the value, but this time we are substituting a different value. Okay, and so we get a different value from the call option value itself. Alright, so next thing, we also need to find the same thing, which is we need to find the price option at the node 2. Okay, from here the node 2. Okay, the node 2 here, this is node 2, this is node 3, and this is node 1. Right, from the node 1 and the node 2 for the put option, the value is the 0.2767, and then put the price option at the node 3 for the put option, we got 2.8643, and then the next one we need to find the price option of here for the put option. We got the value f equal to 1.375. Okay, as same as before, same as the call option before. It have the same value, which is the put option. The price option at node 1 is equal to the put option price. Okay, alright, that's all for my problem. With that, thank you.
Problem 5. Suppose that X is the yield to maturity with continuous compounding on a zero coupon bond which pays off Rm 1 ringgit at time t. Assume that X follow the process. The equation will be here, and where A, X naught and S are positive constant and dW is a winner process. Find the process followed by the bond price. The process the process followed by B, the bond price is as the formula as I write above. So from here we let B equal to e to the power of negative x t minus t. So from here we differentiate B, it will be like this. We differentiate B respect to t, so it will be the x e to the power e of x and t minus t. So from here we can say that it equal to x to the power of b, and also we can say that and then from here we differentiate respect to x, so it will be like if t minus t e negative x t minus t, so it will equals like negative t minus t of b, and the second derivative of b is this, we differentiate b respect the second derivative b respect to x, it will be like this, negative t minus t minus t minus t e negative x t minus t. So we will get like this, t minus t square to the e to the power e negative x t minus t. So we simplify it, it will be like this, t minus t square, and this one will equal to b, so dot b. So from what we get is for b respect to x and respect to t, we just replace into this formula. So it will be like this, dB equals to negative t minus t b dot a x naught minus x plus x b plus half t minus t square b square x square dt plus negative t minus t b, and it equals to be negative a, t minus t x naught equal to x plus 1 over 2 of t square s square x square dt minus b t minus t s x dz. So that's all. Thank you.
Question 7 is about European put option on a non-dividend paying stock. So from this question, we take all the data. The first is stock price S equal to 69, strike price K equal to 70, interest R equal to 5%, which is 0.05, volatility, which is 35%, 35% volatility. The symbol is standard deviation, so 0.35, and the time T equal to 6 over 12, because 12 is per annum. We can simplify as 1 over 2. First, when we this is a Balck-Scholes question. When we know that this is Balck-Scholes question, we must find the first one. We must find D1. The formula for D1 is ln S over K plus R plus volatility square over 2 times T over volatility times square root of T. Then we fill the formula with this data that we get from the question. Ln 69 over 70 plus 0.05 plus 0.35 square over 2 times 1 over 2 over 0.35 times 1 over 2. Okay, then when we fill the formula with this data, we get D1 as 0.1661964. After we find the value of D1, we must find value of D2. The formula for D2 is D1 minus volatility times time square root of time. So we just fill it with D1 0.1661964 minus 0.35 times with square root of 1 over 2. Then the D2 value of D2 is negative 0.0808977709. Okay. After that, when we have the value for D1 and D2, we can find the put value. Put value formula is P equal to K E negative R times T and negative D2 minus S N negative D1. Okay, this is formula for put value. After that, we can fill it with the data that we get 70 70 E negative 0.05 times 1 over 2. Okay, we can find n negative d2 from the normal distribution table. So this negative d2, the answer is negative, so the value is positive 0.008 minus S 69 n negative d1, so n negative 0.17. Okay, the value of n negative d2 and n negative d1, we can find it at the normal distribution table. So when we fill the value of this 0.5319 and this 0.4325, okay, we get the answer 6.4712. So this is the value of put value. Okay, that's all for the question number 2.
Hi, I'm Azlan. I will tell you about the Black-Scholes. Okay, what is Black-Scholes? Consider a stock whose price is S. In a short period of time of length, T, the return on the stock difference between S divided by S. S is a mean to the price. Is assumed to be normal with mean and standard deviation. Mean is expected return and standard deviation is volatility. The concept of underlying Black-Scholes. The auction price and the stock price depend on the same underlying sources of uncertainty. We can form a portfolio consisting the stock and the option which eliminate these sources of uncertainty. The portfolio is instantaneously researched and must instantaneously earn the risk-free rate. Okay, next is properties of Black-Scholes formula. S has not become very large. C tend to S not minus K times exponential negative RT, and P tend to 0. And S has not become very small. C tend to 0 and P tend to K exponential negative RT minus S naught. As my name is Muhammad Azlam bin Muhammad, and I will explain to you about problem 8. Find n prime s. Ns equal s approaching to negative infinity, fu du equal x approaching to negative infinity, fu equal 1 over set 2 pi exponential negative u square over 2 du. So we differentiate for one time, equal d ns over ds, 1 over set to x e negative x square over 2. Okay, show that s n prime d1 equal ke negative r open brackets greater t minus t close bracket n prime d2. So we want to show that for question B, okay, this is the solution for question B. S n prime d1 equal k negative e k exponential negative r open bracket t greater minus t n prime d2 c equal, this is C equal as n d1 minus k e negative r integrators of minus t n d1 in n d2 is a basic question. Okay, so we differentiate to ds over 2ds, dc to ds equal n d1 plus s n prime d1 minus k exponential negative r open bracket greater minus t and prime d2. So we separate each, we bring to the and d1 to the left. Okay, dc over ds minus n d1 equals 0. Equal, so we let dc over ds equal 1 and n d1 equal 1. So 1 minus 1 equals 0. Equal for the right side, we have s and prime d1 minus k e negative r t greater minus t and prime d2. So we take s and prime d1 to the left. So the question we get to prove the s and prime d1 equal k e negative r t greater minus t and prime d2. For question C, calculate d1 over dds and d2 over ds. Okay, this is the solution for the question C. Wait, this is the solution for question C. Okay, now we start with d1 equal ln st over s plus r plus psi s square over 2 times t. So we want to reduce to the confused, so we'll change t into r. Okay, r2. Okay, now d2 ln st s plus r minus psi s square over 2 times r. This is operator. Over divide psi square psi s set t equal d1 minus psi s set t equal t minus t. Okay, this is t. We can represent t to t minus t, or r equal t minus t, and times is the cumulative density function of normal distribution, and d1 equal d1 approaching to negative infinity, fu du equal d2 approaching to negative infinity 1 over 2 pi exponential negative u square over 2 du. First we calculate n square d1 equal dn d1 over d1 equal 1 over 2 pi e negative d1 square over 2. So we can prove, we get the proof, calculate, and we can calculate d1 over d2. Okay, n prime d2 equal d over d2 over d, and d2 over d2 equal 1 over 2 pi e negative d square divided by 2, 1 over 2 pi exponential d1 minus psi s r square divide 2, because we replace t into r. T equal r. This is, I show you, t equal r. to reduce the confuse. So we continue with 1 over set to pi e negative d1 square over 2 times e d1 set s set r times e negative psi s squared r over 2. Now 1 over set to pi e negative d2 over 2 times e ln psi st divide s plus r plus st divide 2 square st square divide 2 times r times e negative psi s square r divided by 2. Okay, now we conclude. So we get this 1 over set to pi e negative d1 square over 2 times st over s e negative e r greater, because we have replaced with r. Okay, 1 over set to pi exponential negative d1 square over 2 times st over s e r greater equal r equal t equal t minus t. This is t minus t. Okay, to replace. So solution is 1 over set to pi e negative d1 square over 2 times st over s e r t minus t. Okay, for the question C, we have get the solution. Next, we continue with question D. Show that dc over dt equal negative r k e negative r t minus t and d2 minus s n prime d1 size of divide 2 pi to greater minus t. Alright, this is the solution for the question D. Okay, we start with, we replace is t equal t minus t. Okay, negative st d and d1 divide d is t plus negative r k times e negative r t negative r times k e negative r t and d2 plus k e negative r t d and d2 over dt. Okay, negative st d and d1 over d1 d times d1 over dt minus r times k times exponential negative r t and d2 plus k e negative rt dn d2 over d2 differentiate to the d2 d2 over dt. Negative st 1 over set to pi exponential negative d1 square over 2 open bracket 1 plus psi s square over 2 divide psi s set t minus ln st divide s 2 psi s t 3 over 2 minus r plus psi s square over 2 divide 2 psi s set t minus k e negative rt and d2 plus k e negative rt open bracket 1 over set to pi e exponential negative d1 square over 2 times st divided by 2 times ert close brackets. Okay, times we are open brackets back r divide psi s set t minus ln st over s 2 psi s t 3 over 2 minus r plus psi s square over 2 psi s set t equal negative st 1 over set to pi e negative d1 square over 2 open brackets r plus s square over 2 psi s set t minus ln st over s divided by 2 psi s t 3 over 2 minus r plus psi s square over 2 psi s set t minus r times k times exponential negative rt and d2 plus st 1 over set to pi exponential negative d1 square over 2 times open brackets r psi s set t minus ln st divide s divide 2 psi s t 3 over 2 minus r plus psi s square over 2 to psi s t close bracket equal negative st 1 over set to pi exponential negative d1 square over 2 open bracket psi s square over 2 psi s set t close bracket negative rk e negative rt and d square equal negative st psi s divide 2 psi t and prime d1 minus rk e negative rt and d2. So this is we can conclude this is the solution for the question D. Alright, this for question E, show that dc over ds equal n d1. This is the solution for the question E. Okay, we let t equal t greater minus t. bc over ds equals any1 plus s d and u1 over ds minus s exponential negative rt d and d2 over ds. Okay, and d1 plus st d and d1 over d1 times d1 divide ds minus s times exponential negative rt dn d2 over d2 times d2 over ds. Okay, and d1 plus s 1 over set to pi exponential negative d1 square over 2 times 1 over st psi s exponential psi s set t minus s exponential negative rt 1 over set to pi exponential negative d1 square over 2 st of s times exponential of t times 1 over st psi s 30, and d1 plus s 1 over s psi s 2 pi t exponential negative d1 square over 2 minus st 1 over st psi s 2 pi t exponential negative d1 square over 2. So both of them are same, so we can reject both of them. So left is just anyone, so it is shown. Okay, that's all. Thank you.